Well, good evening. Welcome to Space Oddities. How are you all this lovely Tuesday evening? As you can see, we've got a bit of a packed house today. So let me just make a few cursory introductions. We're delighted to welcome Aaron back this week. This time we can actually see him, which is fantastic. And you're welcome, obviously, back here, Aaron. Still got a few problems with Aaron's video, but let's hope they sort themselves out in due course. He's still a little bit jerky. We're delighted to welcome to the programme Katryn Raynor and Brian Jones. They are going to tell us all about their wonderful new book, Who's Who in the Moon. And we'll come back to you two a little bit later, if we may. Other than that, we've got the usual rabble here today. Hello, Roger. How are you?
Fine, thank you.
And welcome back, Pete.
Doing well.
Good. Michael, who's got COVID. So don't cough too loudly into the microphone, Michael. Just spread that everywhere.
I've still got the cough, sore throat and all that, but yeah. I'm still here.
Right, you're still here. Good. Daz, how are you?
Oops. I'm lovely, thank you. A bit jaded around the edges after all the Aurora and Perseid watching, but yeah, other than that, fine.
Guys.
And we've also, of course, we'll also have John in a bit. John's on his way. He's had the man round today to install his fibre optics, and that's why he's not here this evening. But he hopes that everything is going to be resolved fairly soon, and I hope he can join us before the end of the show. We hope you're all well. Thank you very much for your donations so far today. Good to see so many of you here today, and hope you've all had a good week. I hope you're all out watching the Perseid meteors last night for the peak night, and maybe a few nights before that. I think the general consensus is that it's been a very bad year for the because I was certainly not seeing. Well, we were seeing a meteor about once every 10 minutes, which is a very low rate for the Perseids. Normally, you can see one a minute or one every 2 minutes. So it didn't see that many Perseids. My daughter was very unimpressed with it, although she got to see some and she was thrilled. But I think everybody said generally it was a very bad year for the Perseids. I wonder why. So there we are. Anyway, we'll just go through the usual stuff. As you can see, we've got a lot of people to get through tonight. Lou is going to be attempting for the third time.
Attempting, yes.
Attempting his presentation about exoplanet and statistics about exoplanets. So we hope that finally gives up the jinx it appears to have suffered recently. And we'll give that a go. As I said, we'll be talking to Katryn and Brian about their wonderful new book. In the meantime, if you would like to support Space Oddities, of course, you may do so by buying us a coffee. You can scan that QR code and the link has just appeared in the chat as well. All coffee gratefully appreciated. As I always say, all money goes towards helping keep the show on the road, as it were. And of course, we have the Space Oddities T-shirts and hoodies. And we have two designs, of course. We have the 2024 design, which is that one. And we have the hoodies as well. You can find all of this and plus the old designs at the Space Oddities shop, which is there. And links to all of those should just have come up in the chat. T-shirts are £25, including UK postage and packing. Hoodies are £40, including UK postage and packing. If you're outside the UK, please add £10 to the total value of your order. So there you are. So get wearing the merch, spread the word. And
Ian's, sorry, Andy, Ian's a little all excited. He said, "Ooh, there's a girl on tonight." So yes, Katryn, you're welcome. You've got all excited. So,
I haven't been called a girl in a long time. So, yeah. I'm well over the age of being a girl.
Ian's probably on the pool. We know him from old. He's probably on the pool.
Take it as a compliment, Katryn.
So I think what we'll do, we'll talk to Brian and Katryn first. Now, Brian and Katryn, believe it or not, we're working for 4 years on a book, this book called Who's Who in the Moon. So tell me, basically, what is it all about?
Should I go first? Or
you go first, Brian. You go first.
Can you see that?
Yes.
Brilliant. Well, the potted history of how this book came about was that, as you know, I do these daily postings. Today's the anniversary of the birth of, or the death of, or whatever. And they seem to be quite popular. And a lot of people were saying, well, why don't you put them in the book? And I thought, that's a jolly good idea, being biased, you know. So I approached publishers, and they weren't interested in doing a January the 1st to December 31st book with something on every day, anniversary-wise. I thought, how insane is this? But then Pen and Sword, the Yearbook of Astronomy publishers, wanted a book on the moon. So I said, well, okay then, but I'd like to fill it full of the biographies that everybody's asking me to put into print. And at the same time, I came across this, which was a BAA memoir written or published in 1938 by Mary Evershed of the BAA Lunar section. And the book contains, if I could just pull, you just bear with me a second, I should have had this. Here we are. And you thought,
got props.
We had, up to that time, whatever craters on the near side of the moon had names, short biographies were compiled and put into this memoir.
Right.
And so I thought, well, this has been done before, but it needs expanding. So the book was written as a tribute to Mary Evershed's original memoir, an expansion of the memoir, but containing biographies that have been featured on Facebook, plus around 70 or 80 from this original memoir. So these were written in the 1930s, and altogether there are something like 300 biographies in Who's Who in the Moon. So I don't know whether, do you want to take over, Katryn, and just talk about the design of the book?
So Brian contacted me in lockdown, I think it was, in 2020. It was a long time ago. I still remember getting the phone call, and he asked if I'd like to kind of co-author the book with him. So, we had a lot of conversations around how we wanted the book to look, what we wanted to have in the book. So it is a bit different to Mary's memoir in that we have like a few short chapters at the beginning of the book written by contributors. So we've covered things like lunar sketching, different names of the moon, how they got those names, and like observing the moon. And then we have the main text as well, obviously. And we've also asked a couple of people that we knew from social media or in real life to contribute to the personal perspectives chapter, I think it's called. So people have submitted photographs that they've taken of the moon with a short explanation as to why they love the picture, why they love the moon, and they supplied information on, the equipment that they were using, and anything that they used to kind of edit the photographs as well. So as Brian mentioned, Brian wrote all the biographies for the moon and did the editing. And my part in the book was to describe the photographs, I guess, to put it simply. So for each section of the moon, we've got photographs with the crater names on them. And it was up to me then to kind of describe those craters and kind of give you a tour across the moon, I suppose. So, Brian was very patient with me. Very understanding. He was good with his advice. And I've really enjoyed working with Brian, but, it wasn't the first time I had worked with Brian. I've written for the Yearbook of Astronomy a few times. So, I'm really pleased with how it's turned out, and it looks fab.
Good. So how many craters did you work your way through?
Oh my gosh, I don't even know. There was a lot.
Well, craters actually named. Not every crater is mentioned.
Right.
But each section of the book, and there are about 25 sections, is headed by a page-wide section of the lunar landscape. And essentially it goes from I don't know, this is putting it really wrongly, but top left and bottom right. And then we've got the libration zones as well. The budget that Pen and Sword had would not allow us to do the far side of the moon. So there is a dormant section on the far side of the moon waiting publication. I don't know.
Volume 2. Volume 2.
Yeah, volume 2. Or if the book goes well, maybe self-publish the far side of the moon. Companion volume. Now there's a thought. I mean, let's face it, the precedent has been set with a 2017 yearbook, so it works, you know. So we'll see how it goes. So
fantastic. I mean, I asked about the craters because there's a crater named after a mathematician in my family on the moon, Crater Briggs. It's don't worry, Katryn. It's an.
I'm going to see if he's in there. Let me have a quick look.
I'd be gutted if he isn't. We'll be saying to you.
I can't even remember. We did so many.
Yeah. No, it's a fairly insignificant crater because I think although he was a mathematician, I think around 1820 or something like that. I can't remember, but you know, for our family to have a mathematician in its history is quite an achievement on its own. So damn right it should be commemorated with the crater. So there we are. So who's actually who do you think will buy this book? Who is it aimed at?
Well, the book is informative.
Yeah,
it answered the call for although not in the format they wanted, getting a lot of these biographies in printed format. Anybody who's interested in the moon, but from I don't know, it's a coffee table book, but it's one you can dip into.
Yeah,
and you can read about the people after whom the craters are named. I mean, there are lots of books about with short, literally 10-word biographies.
right.
The only one that I know of with the full length, there are two that I know of previously with longer biographies. One is Mary Evershed's, which you've seen, the 1938 memoir. And there was a book published about 20 odd years ago by, I think, a couple of brothers in America called Who's Who on the Moon. But the biographies there were a lot shorter.
Right.
And it was a different style altogether to what we did. So, to the best of our knowledge, Katryn and I have filled the gap. So it's a light-hearted book, but it's informative and it's nice to look at.
Right.
The proofs look good. So, you know, and I think it went to the printers today, which, by the way, Katryn, I've got the high-resolution proof of the whole book to send to you for your files.
Oh, okay. Oh, brilliant. Thank you.
Yeah, I'll have to send it by WeTransfer. It's 75 megabytes.
Wow.
Wow.
It's not good as an email attachment anytime soon.
Yeah.
So, yeah. But it was fun to do. And, yeah, that's it. It was the sort of book you could do a few things and put it to one side, in theory.
Yeah.
But towards the end, we didn't get a chance to put anything to one side because the publishers were chasing us up. So, anyway, there you go.
Right.
Who's going to narrate the audio book?
The audio book, yes.
Yeah.
Actually,
Now there's an idea.
Yeah, Brian will need subtitles.
well, what do you think, Katryn?
An audiobook could work. Yeah, you could listen to one biography a day in bed, you know.
I mean, someone's going to nick the idea here, but you could take each of the wide field ones. You could do the talking about, just move south now and you see this crater, move to the guide people across the moon. And the Yorkshire accent could come in with a biography every now and then.
Yeah, that's true. Mix it up a little bit.
Yeah, indeed.
Fantastic.
Yeah, you got to have the Yorkshire accent in there.
Sorry?
You got to have the Yorkshire accent in there somewhere.
Oh, absolutely. Indeed.
Absolutely. Yeah. So, I mean, we better ask the important question: where and when will people be able to buy this book?
Well, I put on the Space Oddities Facebook group today the pre-ordering site for the book.
Oh.
Yeah.
So the pre-ordering site's up and running, and so it's actually on the Space Oddities live Facebook group posting today. You click on the link and you order it, and it's an introductory price. It's £3 or £4 off, or something.
Right.
So
Brilliant.
you know, and apparently if you buy 2 or else 3 copies, you get free postage. But
Oh,
yeah, but nobody wants 3 copies unless you've got friends that you want to buy a really interesting Christmas present for. Then of course you probably want 6 copies. But I don't know.
At least.
Whatever.
I mean, I was going to say it'd make a lovely Christmas present, wouldn't it?
Well, yeah.
Well, I have
and also
have
3 or
seen
4
that,
copies. Oh, sorry.
Sorry, you
No,
can
you carry
actually
on.
buy it on the WH Smith website as well, I think, Brian.
No.
Right, yeah.
Oh, right.
Yeah. I mean, it's due to be published at the end of October.
Right, end
So,
of October.
Yeah.
I presume it'll be on Amazon as well, will it?
yeah, and, well, yeah, I suppose. I mean, I never touch Amazon. Every time I used to try and get on Amazon and buy something, I always got roped into Prime. So I just stopped buying from Amazon.
Right.
I'm the opposite. I'm on there every day.
That's because when it said, "Do you want to be a member of Prime?" you tick the box. That's what it was.
Oh, no,
Yeah.
well, thereby, I'll just digress for 30 seconds. The
Go
last thing we bought from Amazon, we ticked the option that, or whatever, we took the option not to join Prime.
Right.
And yet we got an email welcoming us to Prime. So we phoned up Amazon, and it took them half an hour to get us off. It was like walking in quicksand. Even the last we spoke to did not know how their system worked. And you got the feeling that it's there just to snare people. It's like Hound of the Baskervilles, the Bob. Once you're in it, you can't get out. So I've never touched Amazon. So call me cautious. But
That's internet marketing for you.
yeah, well, this is it. I mean, I don't know. But so I buy all my stuff from eBay, 90% of it.
Right.
And then other things from dealers. But yeah, Amazon, no, here there be dragons. Yeah,
So, team, does anybody have any questions for Katryn or Brian about their book?
Well, I've already pre-ordered my yearly astronomy book, so that's already in the thing. So now I've got to go and pre-order the moon book. So yeah, so it's I mean, just one question. I know we're moving slightly away from the book that you've just written. Katryn, you still collecting stamps?
I am. I've had a bit of a hiatus recently because of personal life issues, but yeah, I still have my collection, and I just did my first talk, I think last week or the week before, the first time in 2 years. So it's still going on in the background. Still trying to do my talks, and I'm really desperate to get a new talk up and running. Because I think I've done my last talk to death now. Probably done it about 60 times. But if anyone on YouTube is listening and wants me to do it, then contact me.
What is it? What is it? Tell us.
Have there been any recent releases of astronomical stamps? You can tell us of?
We had the James Webb issue. Oh my gosh! Now when was that? Was that last year or the beginning of this year?
I think that was the year before.
That was an American issue. So my friend in America sent me a couple of first-day covers. But I'm trying to think if there's been anything else. I think that's been the most recent one.
There you are.
So, there you go.
There we are. Ian's pre-ordered.
Hey.
Well done, Ian. Thank you.
Thank you, Ian. You'll do for me.
Fantastic.
yeah.
Well done. Yeah, I'm sure I'll be pre-ordering as well because I really want to read the book. I need a new astronomy book to read, definitely.
Absolutely. Yeah,
definitely. All right. Well, listen. The very best of luck with the book, you two.
Thank you very much.
And I hope it sells millions. Of course.
Thank you.
And of course, we hope that. It'd be lovely if it did. But we will certainly do our best on Space Oddities to spread the word until October when it's published. Probably afterwards as well. So
and we look forward to the second edition. Who's on the far side of the moon? That'll be fantastic.
Yeah.
Well, it's probably about over 50% done. Well, no, it's probably more than that done. So.
All right.
Well done. And as this is sort of a Space Oddities publication anyway, because Brian's been posting the on this day in who was born for a long time now on the Space
fascinating.
Facebook group, for which you have our eternal thanks, Brian. So it's a spin-off from that, really. So of course we're going to try and help you as best we possibly can.
Thank you.
And you are both welcome to stay with us, of course, until the end of the show. If you have anything better to do, then please don't stay here for the sake of it. But thank you very much for being here and talking about this wonderful book.
Thank you so much.
Oh, sorry, go on, after you.
I was going to say thank you. I've never joined before, so but like I said, I will be leaving because I was recording the podcast earlier, and I've been working all day, so I am ready to just chill.
Okay.
Thank you for
Katryn, you have the link. That link is permanent. So
okay, thank you.
You're welcome to drop in any Tuesday evening if you've got absolutely nothing better to do. Just drop in and say hello. You're always welcome. You know that.
Thank you so much, everyone.
And best of luck with everything you're doing.
Thank you.
I know you're a busy lady. So
Yeah.
I wonder what was Brian going to say. Go on.
Thanks.
Oh yeah. It's not so much a plug as just the latest position. The Yearbook of Astronomy 2025 was printed in India, and it had to come to the UK via the Red Sea.
Oh, wow.
It made it through. It docked last week, 3 days late, and hopefully it'll be in the warehouse ready to send out this week, whatever.
Oh, wow.
So, thank God for that.
Wait in anticipation.
To be absolutely honest, as soon as they said it's been printed overseas, I thought, do they know what's going on? I don't know.
Yeah.
But anyway, it got through. Yeah.
So yes, and we welcome John. Hello, John. How are you?
Hi, John.
Hello.
Good evening.
You've got your new fibre connection then.
Mostly, yes. Mostly.
Mostly, okay. All right. Then.
Mostly harmless.
Yes. Yes.
So that makes 10 of us. So the house is now
Oh.
full. So this is
doors.
the most we've ever
That's
had in one
record.
evening here. So thank you all for being part of it. On this historic evening, we've managed to completely fill the studio. So well done. And anyway, Katryn, please come and see us soon. And it's
Thank
lovely.
you. Yeah, thank you, and everyone for
Best of
keeping in
luck,
touch with me and stuff. So, yeah, I'll see you soon.
Yeah.
Enjoy the rest of your evening.
So lovely. to
Thank
see
you.
See you, Brian, after all these years.
Lovely. Likewise.
We should FaceTime more often.
Indeed.
Yeah. He's saying no thanks.
Well, next on the Space Oddities dating channel, we have.
Yeah, we'll have to tune in on Tuesdays a bit more often as well.
Yeah, I know it's been really good fun. I've enjoyed it.
Yeah, you're both welcome to drop in whenever you want to.
Thank
How
you.
about a short presentation on space stamps?
Yeah, that's an idea.
Very short, so not committed to too much. Yeah. The thing with me, if it was me giving a presentation on it, I won't have a clue which button to press. Seriously. The only thing I know about computers, if you don't recognise it, don't click it.
Well, I have a presentation on space stamps all ready to go. So.
Well, you're welcome to come and deliver that here any Tuesday, Katryn.
Oh, thank you. Yeah, I'll take you up on that. It'd be
Just let us know when you got spare Tuesday, and you're welcome.
excellent.
Okay.
All right then.
Thank you so much for having us both. I don't know if Brian's staying on or if you're going.
Yeah, I'll stay on a bit.
You're staying on, okay.
Yeah.
Till I-
Thank you,
All right.
Catherine.
Cheers,
Thank you.
everyone.
Bye.
Yeah, bye-bye. Bye-bye.
Bye. Bye, Katryn.
Bye-bye.
Well, that was Katryn Raynor together with Brian talking about this wonderful new book. I'll just give it one final plug for you. So this is Who's Who in the Moon by Brian and Katryn. Their project of 4 years in the making. So if you have a look in the Facebook Live group, the Space Oddities Live in Facebook, then there's a link in there to the website where you can buy it on pre-order and get money off it as well. So it sounds most fascinating to read. So there we are.
It's certainly there anyway.
Yeah. So let's move on. I think what we'll do next is we'll go to the news next, and then we'll come back and Luke can tell us about some exoplanets, if that's all right with you, Luke.
Yeah,
Yes.
Roger.
Okay. Right. Well, let me just sort myself out here. Just give me 1 second.
Should they?
And right, so not much news this week, just 3 or 4 stories that have come up. So the first one is that astronomers have seen the biggest and brightest TDE ever. Does anybody on the panel for 5 brownie points know what TDE stands for?
Ooh.
Total destructive event.
No.
Pterodactyl and the P silent.
Pterodactyl extinct.
No.
Time dilation, something.
No. I'll tell you what it is. You're right in that it does end with event. It's a tidal disruption event.
Uh-huh.
And basically, this is the stupid name astronomers give to the event when a black hole swallows a star. It's known as a tidal disruption event. And astronomers have just seen the brightest one ever. And just a few details about it. So this starts off with a black hole of 10 million solar masses. And it's consuming a star that has 9 solar masses. So in other words, a star with 9 times the mass of our sun. And the black hole is swallowing it. Now, in doing so, it releases a lot of radiation right across the electromagnetic spectrum, but predominantly in X-rays. And this is an incredibly bright X-ray object at the moment, which is why astronomers noticed it, because it's incredibly bright. And this is the brightest TDE ever seen. And what astronomers hope to learn from this is obviously the process by which a black hole swallows a star, how it all works, and it'll tell us both about stars and black holes. So this was something lucky that astronomers have seen, the brightest and biggest TDE ever. Then we come to a major discovery based on the InSight data. As you may remember, NASA dropped the InSight lander onto Mars, and for 4 years it studied the interior of Mars, listening for Mars quakes. And what it has found, it detected, I think, 1,307 Mars quakes in that period, if I've got that figure right. But what it has found are big areas of liquid water. Now, we already knew that there's a lot of water in the form of ice under the surface of Mars, but this is the first time that liquid water under the surface of Mars has ever been discovered. This is great news, of course, and it answers a few questions. Firstly, the question for many, many years has been, when Mars froze about 3 billion years ago and became a desert, where did all that water go? Because we know that Mars had rivers and streams and lakes and possibly seas of water as well. So where did all that water go? And the answer is it went underground. And this water is in a layer between 10 and 20 kilometers underground, and it's expected to be global in distribution. So you have a global layer of water 10 to 20 kilometers down on Mars that is liquid, which is quite amazing. Now, of course, it sounds fantastic, but practically you're not going to drill down 10 or 20 kilometers to get at that water. That would be incredibly difficult. Even under Mars' low gravity, that would be an incredibly difficult undertaking. So it's doubtful whether this will be of any practical use for the exploration of Mars in the future. But it's certainly great to know that the water that was originally on the surface of Mars headed underground, and that's where it ended up. So that's a lovely discovery from the InSight lander. InSight, as you may remember, was doing so well, and it told us a lot about Mars quakes and what's going on under the surface of Mars. But it died when its solar panels became progressively more encrusted with Martian dust, and it lost power and died. But it was a fantastic success. You may remember it tried to drill down into the surface of Mars, but they couldn't get the drill to go down far enough. And that part of the mission was a failure. But the listening for Mars quakes was not a failure. It's told us a lot about the interior of Mars that we didn't know before. So RIP InSight.
May I make a comment or two about that?
Of course you may, Lou.
This is an exciting finding and well reported, Andy.
Thank you.
So right. So the big question: where did all the water go? It turns out that the water actually has probably gone three places. All right. So the first is, in no particular order, the water in the form of water vapor got ionized. The hydrogen escaped, and there was further atmospheric erosion from the solar wind when Mars lost its magnetic field and went geologically quiet. So we know that now. That was a thought, and now we know that from the data from the MAVEN mission, the accelerated loss of the Martian atmosphere. Another place that the water went was to be absorbed by rocks on the surface, and so there's some evidence of that from our rovers. And then the third place that you're outlining here, which may be the majority of it, we don't know, and we've had some interesting observations from ground penetrating radar from both the surface and from orbit, is that the water's kind of slipped down through clathrates in the surface. So anyhow, just wanted to make that point that there are three possible places the water went, and perhaps the biggest is the one that you're discussing.
Thank you, Lou. The other thing, there's a caveat here, actually. InSight can only look vertically downwards, which is where it found this water underneath itself, if you like. And it's presumed that this would be global. But we have to say perhaps InSight was just lucky and found the water under itself, but it's not anywhere else. That would be an amazingly unlikely coincidence, but it's still a caveat that we don't know yet exactly what the distribution of all this water is. So there we are. Thanks for that, Lou.
Mm-hmm.
Okay, let's move on. The Chinese are trying to copy SpaceX and launch their version of the Starlink satellites. They want to put up a constellation of their own. And they had their first launch of these satellites this week, and it ended in disaster. So what happened? Well, firstly, the Chinese constellation will be known as the Qianfan, which means 1,000 sails. But rather than 1,000 satellites, they're going to try and launch initially 12,000 satellites. The project is being mounted by the Shanghai Spacecom satellite technology. In other words, the Chinese government, because there's no independent industry in space in China. Everything is done by the Chinese government. So the Shanghai Spacecom company is just a front for the Chinese government, as they all are. The initial launch was on a Long March 6A rocket of 18 satellites, and all the satellites were deployed correctly into their correct orbit, and everything was fine. But then disaster struck, because what happened was the second stage, after deploying the satellites, then immediately exploded, leaving a cloud of debris around the Earth. And you can see that Slingshot Aerospace have taken some images, and you can actually see the debris here, which is inside the rectangles. So a trail of debris. US Space Command confirmed the existence of more than 300 pieces of debris, more than 4 inches in size. And of course, there will be a lot of debris that's much smaller than that is nonetheless still extremely dangerous.
Andy, I think we may be seeing the wrong slide here.
Oh, really?
This looks like one of Daz's slides on solar activity.
Right. Has anybody touched the scenes? Somebody's fiddled with the scene. Right. Just give me 1 second and I'll sort that out. Right. So, yes, somebody's actually been fiddling. Just give me 1 second and I'll go back to where I was, okay? Okay.
Might have been me, sorry.
Keep your hands off. Right, you should be seeing this now.
Yes, please.
Right, okay. Did you see the previous slide?
Saw the Long March.
You saw the Long March, okay. So this is the next slide. So the second stage exploded. Here's an image taken by Slingshot Aerospace, who monitor, amongst other things they do, they monitor space debris. And inside the rectangles there are the actual pieces of debris. the US Space Command confirmed the existence of more than 300 pieces of debris, 4 inches in size. But as I said, there are almost certainly lots of smaller pieces that could cause real damage to spacecraft and astronauts, much smaller than that. There's no immediate danger, say the US Space Command, of any peril to satellites or to astronauts or to the space station. But it's just annoying that yet again a major power like China has polluted the near Earth orbit space.
What do they mean? No immediate danger. You blow up a rocket stage, it sends hundreds of thousands of pieces of shrapnel into orbit.
Yeah, I know.
Jeez.
There is going to be danger, and we know that the International Space Station is going to have to move out of the way of a lot of this debris more frequently. A few years ago, they had to boost the orbit of the ISS once in a blue moon to dodge a piece of space debris, but now it's happening on a weekly basis. Because the near Earth orbit space is becoming a debris field. With Russia testing their anti-satellite weapons and China, doing what they're doing, and we've seen that China just don't give a damn. Do you remember that a few weeks ago that video of the rocket falling on the village? Yeah, and they just don't care what they do in space, and they don't care about safety. And this is the first launch of 18 of 12,000 satellites. So God knows what's going to happen in the future unless they get their act together. So anyway, a bit of a downer. Sorry about that. But, this is reality, that something has to be done about all this space debris. And everybody says something has to be done, but very few people are doing anything. Mainly the expertise is coming out of the UK, of all places, on how to deal with space debris. But something big needs to be done. If otherwise, countries will not be able to launch into near Earth orbit because it will be too dangerous. And that time is.
Well, and I need to. Oh, excuse me. I need to chime in here. This is Aaron, as one of the observers in the crowd. Even if they're successful with all their launches, the idea of 12,000 more satellites up there is a frightening thought.
Isn't it? Yeah.
Yeah.
And I think, from what I was reading, it's only an initial 12,000 satellites. They want to go up to 50 or 60,000 eventually. But the first stage of the project is 12,000. So, astronomy will be killed. Earth-based astronomy will be killed by all these mega constellations. And they're not the only ones, because, Amazon have got Project Kuiper to put their mega constellation up there. There are at least another 5 or 6 either government agencies or companies that I know of that want to do the same. It's going to be impossible to do astrophotography. I'm not too worried about us amateurs because it's something, that is not that important to our lives at the end of the day. But professional astronomers are going to find it very difficult to do any important ground-based astronomy, especially survey work like with the Vera Rubin telescope coming online next year. It's a nightmare. And
Space Guard.
Yeah, absolutely. So it's a bit of an ongoing problem, and everybody knows the problem exists and everybody talks about it, but nothing ever seems to get done about it. Anyway, this is quite fun. The NASA watchdog has savaged Boeing over their construction of their part of the Space Launch System. Don't forget the SLS rocket, which until Starship and Super Heavy was the biggest rocket ever built. And Boeing are responsible for stage 2 of the rocket. This is the rocket, the Space Launch System, that will take humans back to the moon. And Boeing are responsible for the second stage of it. So the American Office of the Inspector General has released a report extremely critical of Boeing in the way that they're building their part of the SLS. It says Boeing's quality control falls far short of NASA requirements, that workers are inadequately trained or experienced, and that NASA oversight is inadequate. And this is bad news for Boeing. It couldn't have come at a worse time. Everything's going wrong for Boeing these days. So what with the Starliner problems and the problems with their aerospace division, Boeing are in a lot of trouble. They are responsible for this second stage of Project Artemis, of the space launch system, to get people back to the moon. And you can see just by the costs. In 2018, its estimated completion cost was 962 million. The current estimate up to the end of 2025 is 2.8 billion. So the costs have shot up enormously, and there doesn't seem to be much justification for that. So not good news for Boeing. Couldn't have come at a worse time. We'll just mention the Starliner. The Starliner is still in orbit. NASA are expected to make a decision this week about whether Butch and Suni will come home on the Starliner or whether they will fly back to the Earth in February on a SpaceX Dragon. That call is expected to be made this week. So that is the end of the news for this week. Let me just stop the share here.
Can I just ask something?
Of course you can, Brian.
Well, so, Ian McIntyre's just made a point related to, are there any international laws about blowing stuff up in space? Fair point.
Not really.
No.
No, Ian. Believe it or not, there aren't.
Because all treaties that have been since the 60s are all voluntary. There's no compulsion to join, and it's the same problem we've got with the Artemis protocols. The Chinese and the Russians have set up their own set of protocols, and people are joining. They're choosing sides, but none. And there isn't. And the thing is trying to get people to agree who's going to police this. They all like to sign these things, but sorry.
Sorry, it's okay. I know this sounds harsh, but the only way this is going to happen is if a Chinese astronaut is killed with a piece of this space debris.
Yeah, yes.
And then they'll think, oh shit, we did this, and then something will be done. But it's like anything else. I mean, I'm not saying that should happen, but it's a sort of logic that needs to play out.
Brian, I'm wondering if even that would do it. Because if you think of the way that Russia has treated its cosmonauts in the past, where they really didn't give a damn about their safety, I think China's got pretty much the same mindset, to be honest. Perhaps it would take that. I don't know. Let's hope it doesn't happen, obviously. But
indeed, absolutely. But I'm just making the point. It's like smart motorways. This is safe. Have a heck. But who takes notice? I don't know. Yeah,
I know. The only real treaty. Sorry, the only real treaty in existence, Ian, is the 1967 Outer Space Treaty, which is basically to do with who owns what, and it established a principle whereby no single country or individual can own, for example, any part of the moon. But that's really the only legal treaty that there's been. And the major players didn't sign it anyway. So, it's never been put to the test legally. So, don't know.
I mean, that treaty you're on about, Andy, also said space for all.
Yes, absolutely.
And it's just a case of that. Like I said, everything's voluntary, and there's no one to actually police these things. I mean, really, there's no one to actually a control system, people who are controlling or monitoring all this bit of space debris. There's no actually official body to do this. But everything's voluntary, and it's trying to get people to come together and realize, look, this is getting silly. But all they're interested in is getting their mega satellite structures up there. So
yeah, indeed.
Yeah, I mean, does this the mega constellation spoiling the visual astronomy? Does that go against the space for all idea? Space for all includes astronomers.
Yeah.
You know, I mean, who's going to pay the people behind the Rubin thing? Who's going to pay them the compensation? China, Russia? I think not. You know, yeah.
Ian also says, I thought there was something against nuclear weapons in space. Does anybody? I don't think there is that either, is there?
Well, there's supposed to be, but you never know.
Anything in law. Again, it was a sort of a gentleman's agreement, I think.
Yeah, exactly. I'd say there's not supposed to be nuclear weapons in space, but
we all know there are.
Well, we're not supposed to be militarizing space.
Yeah, that's right.
There's no way to enforce this. We have a United Nations. They can't enforce anything.
Yeah.
We just have, and it's only a silly idea if it doesn't enrich your pocketbook. Right?
That's right. Yes, because if you remember Reagan and his Star Wars project, everyone was up in arms about that, about the militarization of space. But nothing would have happened if they decided to go ahead with the project. It would have happened. You know, thankfully they saw sense and didn't. But that's a long time ago now. All right then, let's move on. Firstly, can I just say a big thank you to everybody at Astronomy Ireland for being such wonderful hosts as always. Last night I gave a talk about the moons of the solar system to Astronomy Ireland last night, and it was lovely to see you all, and thank you so much for having me, and I hope you enjoyed it. So thank you. That was a great evening. And what we're going to do now, we're going to go to Lou, and we've got fingers and legs crossed here, and every appendage we can think of we're crossing, because Lou's been trying to deliver this presentation for a little while, should we say. I can't see it at all now.
That's because I'm going to share it from my screen.
Okay, right. Well, go ahead then. And Lou's just setting that up. So Lou and I were talking about the statistics behind exoplanets, because as you know, we've discovered 5,641 exoplanets, I think it is at the last count. And we were talking about, the statistics. What type of planets are they? What are we finding out about the generally about these types of worlds? And so let's just have a look at this. So take it away, Lou.
Yeah, thanks. And this is so timely. We're screwing up our Earth so badly with all the debris in orbit. We won't be able to leave at some point, but there are always other planets that we can screw up. So this is very timely presentation. As Andy said, this is Space Oddities. We pride ourselves in critical thinking, and we are a program of science. However, I'm starting to wonder if there's other forces afoot that are keeping me from making this presentation. We will find out tonight. Okay, so we're going to talk a little bit about how we discover exoplanets and how that feeds into the statistics of their identification, their discovery, and how we understand their attributes. And as Andy said, this was something that he proposed to me as an interesting topic. So let's see if we can do this. But as I was kind of pulling this together, I came across something very interesting. And that is that the first evidence of an exoplanet was actually made in 1917. A Dutch-American astronomer, I just have to present this because I think it's so cool. A Dutch-American astronomer, Adrian van, and I think it's Manen is how it's pronounced, but however that is, was observing two stars that had very high proper motion. Now, our audience will remember that proper motion means how the star is moving across our field of view, because stars move, as all things in the universe do, presumably. And so if we see a star appearing to move rather quickly across our field of view, we know it's rather close, right? And the ones that are very far away, we can barely detect their motion at all, if at all. So he was looking at two stars that were fairly close together. And this was one of the pair of stars was an F star, and it was the identification, the proper motion was measured and it was kind of put away for a while. And then a few years later, it was looked at again, and it was a rather surprising finding. This star, it turns out, was rather dim for an F star, certainly for an F main sequence star. And it turns out that it's not a main sequence star at all. It's a white dwarf. So it has a very small area, and therefore a lot of photons. But it wasn't recognized as a white dwarf because it has a lot of higher metal absorption lines in it. And white dwarfs, generally, you see only hydrogen and helium. Well, hence the discovery. This is thought to be a planetary system that had a sun that went nova, became a white dwarf, and in the process, there are remnants of the solar system colliding with each other, reducing their angular momentum and sending material down into the white dwarf that's absorbing it and then producing these absorption lines. So this was actually the first that we know of evidence that there is a planet orbiting around another star. Okay, I went off topic for just a minute, but for good reasons, right? Okay, so the statistics of exoplanets. There are a number of ways to detect exoplanets. Here we see 7 of them. There are actually a few more that are less consequential. And the technique that we use to detect these planets bears strongly on how many of them we detect and what we know about them. So although we've done this before, I'm going to kind of quickly go through these 7 different detection methods so that when we get to the statistics, you will understand how these various methods play roles in our discovery of the planets. Okay, so pulsar timing is one of them. And very simply, this is that a planet orbiting a pulsar can change the pulsar timing just a little bit, just enough that we can notice it. And if it happens in a cyclic fashion, that's pretty good evidence that there is a planet orbiting that pulsar. We also have both astrometric and radial detection methods. So if a planet is orbiting a star, the planet's mass pulls on the star as it's orbiting and moves the star around. In fact, the star and the planet orbit some barycenter, which could be buried inside the star or could be outside the star. This produces 2 effects. One, that the star appears to be moving side to side as we look at it in a telescope. That's an astrometric identification. And that's great as long as the star is close enough. But if the star isn't close enough, then we can't measure the side-to-side angular measurement motion. It's too small. However, the star is also moving back and forward away from us and towards us. And for that, we can detect its Doppler shift. And that is not dependent on its distance. That is only dependent on its velocity. So one would expect that you would see more radial velocity detections than astrometric detections. And in fact, we will see that's the case. This is just some actual data of 51 Pegasi. Everyone knows about this exoplanet when it was first discovered, and it was detected through the radial detection method. And you can see here the actual data with error bars on it, on the essentially the velocity, which translates into the Doppler shift. Then we have transit detection method. And this is quite simply that the planet moves in front of the star and dims the star's light for a period of time. And this happens over and over again at regular intervals. And that tells us not only that there's a planet orbiting that star, but by the depth of the diminishing light curve, you can tell how large the planet is with respect to the star. By the angle of the curve and some of the other features, you can tell if the planet has an atmosphere. You can tell what the inclination of the orbit is if you know the size of the star, all kinds of cool things. But the planet has to be orbiting almost exactly in the plane of our vision. If it's not, then it won't pass in front of the star as we see it. This is what it might look like if you had multiple planets orbiting a star and were able to use the transit detection method to detect those multiple planets. You'd see periodic dropouts in the light curve. Okay, we've talked about astrometry, so we'll just move on from this slide. Detecting the planet's wobble. Spectroscopy. As the planet moves in front of the star, the planet's atmosphere, which is cool with respect to the temperature of the star, if it has its composition, will absorb light from the star, and that light absorption will be reflected in absorption lines in the stellar spectrum. Now, the absorption lines are not large because you're dealing with very, very, very tiny absorption features based relative to the noise of the instrument. But we now have instruments that can, in fact, detect that. So the star plus the planet, subtract the star's continuum, and you get the planet spectrum. And here's kind of an example of, this is actually a circumstellar disk around A Tauri. And here's an example from the James Webb Space Telescope of, now these look like they're in emission, but you really just turn it over if you want to find, and these lines are in fact in absorption of water vapor in a planetary atmosphere. And of course, we can image the planet, right? This was thought impossible 20 years ago, but now we can actually, we have good detectors, good telescopes, good methods, and we can image planets around another star. Here, the planet in question is red, around 2M1207b. This was the first planet that was actually imaged around another star, and that's in 2004. This is actual data that was taken over I think a 20-year time period of 4 planets orbiting an exoplanet. This was taken from the Keck Observatory, and there are 2 methods being used here. One is that there's a mask put over the image of the star to kind of block out the bright starlight. And the second is that Keck is using adaptive optics. So you put those 2 very powerful techniques together, and you can detect planets around other stars. However, planets are dim, stars are bright. And so this is very, very difficult to do. So you need powerful telescopes like Keck and powerful methods that we discussed. So probably you're not going to see a lot of those detections yet. I think this may be the last one, gravitational microlensing. This happens when the star and planet system in question is relatively close to us, and a distant star kind of behind it, so that the planet-star system passes right through the light of the distant star. And from general relativity, you have a situation where that light is distorted as it bends around the nearby star. And because there's a planet involved, the light is distorted from the planet, and you get a little bump in the light curve. And that is also a method of detecting an extrasolar planet. But as you might imagine, that doesn't happen quite so often, where you have the right star moving in front of another star, directly. So we're not going to see as many detections from these kinds of methods. Okay, and this is actual data from OGLE, observational gravitational lensing experiment, I think is what it stands for, of an actual exoplanet detection around another star, showing its little peak in the light curve. Okay. Now you know 9/10 of the ways we can detect extrasolar planets. This is from the NASA Exoplanet Archive, and it shows over years, up through today, the relative number of observations made from these techniques. Some of them, most of them we've talked about, some of them we haven't. But notice that by far the most discoveries have been made through the transit detection method. And one of the reasons that's the case is that we've sent up spacecraft such as Kepler and TESS, the transiting extrasolar survey satellite, to survey hundreds of thousands of stars. And so they've done a fair amount of photometry detecting transits around other stars. So we have a lot of contribution from those. Radial velocity, that's not dependent on being in the line of sight. That's not dependent on distance. So the next most common way of detecting extrasolar planets is radial velocity. And you'll notice, let's see, astrometry, just to make another point, in gray here, you can barely see it, right? So that's the graphic. Here are the numbers. And I'll just, let's see, I think let's just in the upper right, if we just look at the panel in the upper right, we see what we expect. I think the first astrometrically discovered planet, exoplanet, was in 2020, okay? And so now we have 3 identifications. All right. Direct imaging, we have 82. Not a lot, but given how difficult it is to measure, that's pretty successful. Lots of radial velocity, and by far the most transit detection methods, and so on. So let's move on here a little bit, and let's look at some of the data. So this is a graph of mass on the y-axis and orbital period on the x-axis. And you'll notice that the transit detection methods, for example, are in green here. And it is about what you'd expect. If the planet is orbiting close to its star, then the angle, its inclination angle, making it, into or very, very close to our line of sight, is not as sensitive. Okay, and so that planet can orbit with a greater range of inclinations, and we can detect it through the transit method. Versus if the planet was very far away, then that inclination angle is very sensitive, and we might not detect it. So you expect to see lots of planets close to their star. I mean, look at this. Oh my goodness, a period of a day or 10 days. I mean, these things are orbiting so close to their stars. And you would expect these to be larger planets. The larger the planet, the more light is blocked out, and the more chances you have to observe. So transit detection method, once again. And here again, the next most populous method of detecting planets is radial velocity. So here, what you want is a massive planet, all right? So you would tend to think that these red dots would kind of tend to be high on the graph, and you want a massive planet because you want it to pull on the star a lot so that you get a very high radial velocity change and a strong redshift or blue shift. Microlensing doesn't happen that often. You see a spattering of those. And once again, poor astrometry. Great idea, but very, very hard to detect unless that planet, the star-planet system, that exoplanet system, is very, very close. Microlensing as well, very hard to just the number of opportunities that you have to detect with microlensing are really, really small. Here's another way of looking at it. Radius, right? How the volume, the size of the exoplanet versus its orbital period. Once again, transits win the day because you want large planets orbiting around their stars very close, and that's exactly what you see here. Although I'm a little, yes. So imaging, you want that planet to be as far away from the star as possible. so that the light from the star doesn't obscure your view of the planet. So one would expect that the blue stars here, representing imaging, would represent detections of planets that were further away from their star. And that's exactly what we see here. This is an interesting graph, and I'll show you the graph here. It's almost all transit detection, but what's important here is not so much the detection method, but what it shows. This is the same graph. You can kind of go back and forth and see they're very similar, okay? But this is kind of a cartoon of that data. And what you see in the red dots, the bright red dots on the right-hand side of your screen, are exoplanets that are essentially Jupiter or large Jupiters, or maybe large Neptunes, that kind of thing. These are planets that are hydrogen and helium, essentially, and you can even see the creators of the graph were nice enough to put some of the planets in our solar system on these graphs to show where they would occur. So on the x-axis again is mass, on the y-axis is density, and you can see how that varies for different compositions of planets, from very dense planets in the upper portion of the graph, iron, to very not dense planets in the lower portion of the graph. Now you might say, well, okay, I understand how I can get the volume of the planet, see how much the light is cut out from the planet. I know how to get the mass of the planet if I understand the mass of the star by how much the planet is moving toward us and away from us with the Doppler shift and so on. But how do you get density? Well, here, let me go one more here. Well, that becomes easy then. Density is mass over volume. And if you can get, and you know the equation for the volume of a sphere, 4/3 pi r cubed. And so if you can get the size of the disk of the planet, and you make the assumption that the planet is spherical, okay? That's an assumption. Planets that are very close to their stars might not be. But so assuming that, you can get the radius of the planet, and then you get the mass of the planet from the Doppler shift, and you put those together and you get a density, okay? And you can also, so this is how the data works. You're detecting the dropout, the delta F, or the change in flux of the star from the planet moving in front of it. And because we're talking about area, we square the radius, right? And so it's just the square area of the planet, or the square area of the star, gives you the percentage of the flux dropout. And we don't need to go over too much more of this, but this is it. This is the idea. Transit detection method on the bottom, radial detection method on the top, and that's how you get density. This is from the NASA Exoplanet Archive. If you've never been to this website, it's a marvelous website. It will tell you more than you've ever wanted to know and ever wanted to admit that you know about exoplanets. It has graphs galore. It has pictures of or artist concepts of exoplanets, and will tell you how many discoveries there have been versus mass, density, observation type, you name it, and all of the latest. And it's kept up to date. So I don't know, you might, this number, 5,741 planets, that was last week, all right? So I guarantee that number will be a little higher today. Confirmed planets. It's happening. The discoveries are happening that fast. So that's the NASA Exoplanet Archive. Go check it out. It's an amazing resource. And this is a kind of a cool plot. If you go to the website, it animates. I don't know why this one isn't animating for me, but these are the locations of all of the 5,000 plus exoplanets that we have discovered to date. And it starts in 5005 with the first detection, and it'll blink onto your screen. and then very quickly you'll start to see others collect. So the pace of exoplanet discovery is increasing. The methods are getting more sophisticated, and the observing tools that we have with, what do we have, an ELT telescope that's going into production shortly, and other great technology advances. We're going to be discovering many, many more in a very short time frame. So that's it for exoplanets, and it seems that we are in fact a program of science, and we will not give any credence to those thoughts that there were gremlins keeping us from presenting this material.
Okay, great. Well, thank you very much, Lou. That's wonderful. I mean, I have to ask you, Lou. I mean, you know, we've thought for a long time that our own solar system is somewhat unusual, and it seems that the more exoplanets we find, especially when we've got things like hot Jupiters and planets in places where, you know, we didn't expect to find planets, and types of planets we didn't expect to find, it makes our own solar system look even more unusual, doesn't it?
In a way, yes, and in a way, no.
Right.
So we started finding these hot Jupiters, these massive Jupiter-type planets orbiting very close to their stars, right?
Mm-hmm.
And we thought, well, that's odd. Maybe our solar system isn't so unique. But in fact, when we look at the Grand Tack model of our solar system, and which is all done through computer modeling, we understand that in fact at one point we had a relatively hot Jupiter and a relatively hot Saturn.
Yeah.
But we're much closer to our sun than they are now. So our solar system today doesn't look like that, but in the past, it probably did.
Yeah, yeah, yeah. And also the distribution of planetary sizes in our solar system is quite extreme, isn't it? Because we go from things the size of Mercury right up to the huge gas giants. And I think in terms of exoplanets, that's quite important. But then, of course, we haven't got the technology to detect really tiny planets like Mercury yet.
Maybe not Mercury, but we're starting to detect more and more Earth-sized or roughly Earth-sized planets. We'll get there.
Indeed. Fascinating. Well, it's a subject I know we're going to return to because, you know, it's one of those things that is, as you said, Lou, constantly changing, constantly updating with constant new discoveries. So I'm sure, you know, I hope the viewers are excited about it as well, because it's something we'll definitely be returning to. And with Lou's expertise, we'll keep you up to date with all the latest exoplanet information.
Yeah,
so there you are. Yeah, thanks for that, Lou.
So this is Aaron. Lou inspired me to go out and take a look at the NASA Exoplanet Archive. And just for your information, they have 2 more on it now than what you were showing in your display.
Okay.
2 more confirmed. Yeah, just saw
Yay.
that. Yeah. So, viewers, if you have any questions for Lou about any of that, about exoplanets, don't hesitate, as always, to put them in the chat. Now, what I'd like to do now is have a chat with Michael, because Michael's got some good news to tell you about something new in Space Oddities. Michael, what's happening?
Right. Some of you may know that I've been producing a magazine called Capcom for 30 odd years. Started back in the early 90s originally for Midland Spaceflight Society, a group of spaceflight enthusiasts. As you know, back then it was not easy to get news about spaceflight before the internet. So some of us had news releases sent through the post to us about what was going on, and we thought, why not put it into a newsletter and start something like that? And basically, it's been going ever since. So it was just a handful of people in the society, and we met in Birmingham every couple of months. And it was set up originally by David Shaley, the author, spaceflight author, and Andy Salmon, a spaceflight enthusiast. Sadly, in 2012, we lost Andy to MS. and unfortunately, Andy was the mainstay of the group, really, and the meetings basically faded after that. So, but we carried on doing Capcom. I've always said that Capcom is written by the enthusiasts for enthusiasts. All of the articles I use are original, sent to me directly from usually people I know. And basically, what I did in 2020, I did set up a company to try and bring Capcom commercially. Unfortunately, a couple of years later, due to personal reasons, I had to close that company. But I still managed to carry on producing Capcom, and but now I thought, what outlet can I use to actually bring it under? And I thought, why not offer it to Space Oddities? So I spoke to Andy last week, mentioned it, and they said, what a great idea. So from the next edition, which is September, Capcom will become a Space Oddities publication, published once every 2 months, so 6 times a year, and it will also be free to download as an internet publication. So that's basically it.
Right, so you've got that coming as a Space Oddities publication. If you'd like to give me 1 second, I'll show you what it might look like. Just give me 1 second. I did have this set up earlier, but it's gone. So just give me 1 second to just set this up. And give me 1 second. We have produced a sort of a mock-up of what it might actually look like.
Yeah.
So this is what it might actually look like. Hopefully.
Mm-hmm.
Or not. There we are. So so that's what the front cover might look like. So how are you actually going to offer this to people?
Actually, at the moment it will be accessible via Google Drive. We could do with setting up with a website with it. I know you've been working on Space Oddities website, Andy.
Yeah.
Perhaps we could talk about that again. And it'll just be like a Google Drive link to download it. We're always looking for articles, original articles on anything to do with spaceflight, astronomy, and any features you want to talk about, and even photographs now. Because I mean, with the quality of PDFs now, it's really good. It's really easy to reproduce photographs as well for newsletters like that. And at the moment, it started off 30 years ago with just 4 pages. It's now 16 pages long, and but that was limited because of the printing run and the cost. But now, as it's going to an internet document, there's obviously no limit to the number of pages we can use, depending on content.
So there we are. We will offer that from September. We'll tell you more about that as time goes on.
I was just thinking, Andy, that cover, the way things are going, you'll be able to use that cover for 3 or 4 months, yeah? So we're going to have to design a new one.
If not for the next year, absolutely.
Yeah, exactly. Yeah.
Okay, so let's now move over to...
Yeah.
Sorry,
I'm having to disappear. My apologies.
That's fine.
That's okay.
Thank you for coming. Thanks for joining us.
Thank you very much for coming, Brian. Nice to see you. Will you come back? Will you come back soon and tell us a bit more about the Yearbook of Astronomy for next year?
Oh yeah, indeed. No problem. Once it actually appears, in the shops, whatever. But yes, and hopefully once or twice more as well. Sort of tune in just for the general camaraderie.
Right.
Yeah.
It'd be nice to see you, Brian.
Well, Brian, you can just turn up any Tuesday. Any Tuesday, you just turn up and tell us about it.
Brilliant. So that same link works, does it? That same link?
Yes, it's permanent. Always works.
Lovely. Thank you. Right. Take care, everybody.
Lovely to see you, Brian, and thank you
Yeah,
for
Brian.
the
Thanks a lot.
Facebook group.
Andy,
Thanks,
are
Brian.
we going to go to Roger?
Yeah, we are going to go to Roger now. Yes.
Hey.
So we haven't forgotten you, Roger. We
Oh,
Past his
we do things in
bedtime.
a slightly
Past
different
his
order this week. It's the anticipation. You see, we like to create a sense of anticipation.
Yes.
Past his
I was going to
bedtime.
say dread, but I think we'll leave it with anticipation. So, Roger, what's been going on? For goodness' sake, what's going on up there in the heavens?
Oh, well, there we go. So here we go for the share my screen.
Yeah, I'm just doing that. There we are. There you go.
Right, so we're working our way through August, and we're currently experiencing just half the first quarter. We'll be going out to the full moon next Monday, and this is what was visible on the sun today. So I'm sure Daz will give us an update on the current activity with what's been happening in the night skies with the aurora. But still a bit of activity on the go here in white light and in calcium there on the right. So there we go. And that was the moon last night on its first quarter. So through the night, as we have here at midnight through the week, we've still got the Milky Way coming through nicely in the southern skies with the galactic core still visible. We've got Saturn rising up nicely now through the southeastern skies, and dominating overhead is the summer triangle. So all's looking well quite so far. And then during the wee hours of the morning, we've got Neptune, Uranus, Mars, and Jupiter coming up through. Now, over the next 24, 36 hours, Mars and Jupiter will be at quite a close conjunction tomorrow morning and the following morning. But tomorrow morning is the best time for seeing it. And when I just move it forward, we will be able to see, this was the picture last night. Jupiter is down on the lower left with Mars at about a 2 o'clock position there. I'll just mark them up.
Beautiful.
Oh yeah.
So that was last night. So obviously tonight and the following night they will be almost be at its closest for quite a while. And in a telescope situation that I've got here, with a square sensor on my 1 meter long focal length telescope, you can get Mars and Jupiter in the same field of view. So a very good opportunity. But no doubt, as we've had clear nights in the last few days, it will be cloudy. But we've still got the opportunity of them to be still fairly close the day after. This is what it's like at 20 to 4 tomorrow morning, as you can see how close they are. And the same time the following day, they are still reasonably close together. So, but after that, then they start to rapidly separate from each other there. Now, just as the sun is going down, we've still got Mercury and Venus, but they are still very dangerously close viewing wise to be able to see anything properly. I mean, Mercury being so small and fainter anyway, it becomes much more of a target and a challenge, but never mind. But as it slowly goes through the week, it will then become a morning object and later on in the month. So that's a better thing. Obers is in Coma Berenices. It's not doing so well now with the magnitude, and as we can see from today, it's 8.2, and by the early part of September, it's faded to 9.8. So we've lost nearly 2 magnitudes of brightness there. But with Comet Shunnarshun Atlas, that's doing better. It's currently in sextans, between sextans and crater, So that's not doing too badly. So it goes from 8.1 down to 5.8 by the first week of September. So things are still looking hopeful for a naked eye visible comet, which we haven't seen really since 2020 with Neowise.
Can I ask you a question, Roger?
Why not?
Or maybe the whole panel, I don't know. These visual magnitudes that are reported, when you have a visual magnitude for a star, it's a point source, and so all that brightness is focused in that one point. A comet is a more diffuse source, and I wonder if the magnitude is a kind of an integrated over the whole comet, or if kind of each piece of the comet is essentially that magnitude. I've never really understood that.
No. Well, I guess it would be more towards the core end of the brightness measuring scale, but obviously calculations are made based on the composition and its albedo and its distance and all the rest of it. So I'm not quite sure on the precise calculation of how that precise magnitude is calculated, but I'm sure someone can give us an idea.
So look it up. I have ChatGPT right here.
Okie dokie. Right, so we've still got the Perseid meteors, and as everyone has been mentioning, it seems to be a bit of a slow show this year. This was a picture that I took last night through the night when I got back from my Aurora show down in Dorset, and these were two pictures combined to show you what I managed to catch out through the night. So one fairly bright and the other one not too bad, but the composition of the two meteors seemed to be very similar. Looking at the trail of the images that I've got, they sort of go from a sort of a goldy colour to a greeny colour. So obviously the composition of the materials from these comets are very similar for the Perseids.
So you actually got 5 meteors in that shot.
No, those are 2, and then you've got the rest of the streaks are just satellites.
Oh, the satellites, are they?
Yeah, it's all that Chinese space debris. Okay, now we have the biggest ever gallery I think we've ever had on Space Oddities this week.
Fantastic.
Everybody has decided to put lots of pictures in, so we have quite a lot of images, but not from too many people. So people have put in multiple images.
Great.
Which is quite good, including our fellow studio person, Michael. And he's got some pictures here taken with a phone of a sunset over Clee Hill. And this is what we've got.
Oh, very nice, Michael.
Taken from near Beauty, looking over Clee Hill, and you can just about see the radar dam on the top of the hill.
Oh yeah, I see.
A typical British scene, the rolling hills, and
it had beautiful muscular rays in it as well.
Yeah, and we've also got another one from Michael of with his phone of Jupiter and Mars.
Yeah,
which is
actually.
Yeah. So
I actually got up at before 4 o'clock in the morning and put my phone on the tripod.
Good, brave, Mike.
I know.
It's great, isn't it?
Yeah. Thank you, Roger.
That's all right. And he's put an enhanced version of just to brighten things up, just in case you couldn't quite see what it was in the first image. But it's got. I mean, you can see all the Pleiades stars there very clearly, Michael.
Yeah, that's right. Yeah,
you've done very well there.
I think it's about a 10-second exposure, actually, something like that.
Right. This is one from Pete of M16, taken with a 2-meter telescope, so not from his back garden. This was when Pete was working with these organisations, and he could get some time on it.
It's gorgeous.
It's gorgeous. Now, I'll just go back to the details, because this was 30 seconds in red and blue. 30 seconds exposures,
Mm.
and he's got that.
Yeah.
So obviously the aperture, the light bucket of a 2-meter telescope does make a bit of a difference.
Yeah.
And obviously with the focal length of that, you've obviously got good close-up details of the pillars of creation there.
Yeah.
Very good. So moving on, we've got one that Pete did take in his back garden with his Coronado with a point grey Grasshopper USB 3 camera. And this is some of the details of the solar activity.
That's
Look at
nice.
that. That's fantastic.
It's great, isn't it? Yes. I'm getting hot looking at it.
I want to make toast.
Yeah.
I could make a nice wallpaper.
And last one from Pete is of the Milky Way, which he does from a location not too far away from him.
Yeah, that's lovely, that is.
Yes.
Stunning.
Quite amazing. It's nice when you've got a nice dark sky sight and there's nobody else there. Right.
Also,
hang on. We've got the Rosette Nebula as well from Pete as well, which he's obviously taken with another remote telescope of a Takahashi 90mm.
Oh, Pete, fantastic.
Oh, wow.
How about that then? Very interesting. Lots of details there. Very good. Okay, so we've got Graham Turvey, who's been using his Sea Star.
Oh,
wow.
And that's come out rather nicely.
Yeah.
Great for the moon, aren't they?
It has come out nicely, hasn't it?
Very nicely. So well done. And Jerry, who's got the Pac-Man, and this is with his usual setup. And here we go.
Oh, look
Look at that.
Lovely colour.
Very nice.
Lovely colours.
Lots of details there.
Yeah.
Yeah, all the dark clouds and all sorts there. Amazing. Okay. Right, now we've got one of Lee's down at the Delabole Fire Station. And he's got that with the Milky Way.
Oh,
it is a composite, but even so.
That's
That looks stunning. Well done, Lee. Even though it's a composite, it's fantastic.
Yeah, absolutely.
Absolutely.
Well done, Lee. And then he went out looking at imaging for Perseids and managed to get an aurora display.
Wow.
Ooh, lovely.
Ooh. You're cutting off the bottom of the picture. Thank you. You're cutting off the best bits. That's well done, Lee. I had something very similar to that last night.
Very
nice.
Lots of columns there, pillars. And one from another member here, and he was just trying out his new mount. So this is what we got from there.
Oh,
John.
Oh, yes.
Oh, yes.
Well done, John.
Yeah.
Yeah. Very nice.
That came out well, didn't it?
Yeah, it's all right.
Good old pinwheel.
Yeah.
Yeah. Well done, John. It's great.
Very nice. And I've got a few here from Kenneth. Now, he's in Norway.
He was in Bergen, isn't he?
Yeah, near Bergen.
Near Bergen, yeah.
Yeah. So he sort of has to put up with this almost on a daily,
a nightly basis.
Yeah, not again. How can I go to sleep with all these bright lights on that go outside? But this is looking vertically up.
Wow.
With the rays coming down. He's very lucky. And this next lot are just some of the other ones that he manages to get almost on a daily basis.
Wow.
Not that I'm jealous.
No, of course not.
Of course not.
Who could possibly be jealous of that?
Well, you would never see the Perseids with all that on the go, would you?
No, you wouldn't.
No.
Swings and roundabouts.
Yeah, I'll tell you a story about that in a minute.
That's why I mentioned it, Daz.
Okay.
Right, now this is one of my images from last night of the aurora, but some camera club people and I went down there just to do the Milky Way, but we were optimistic that there might be some aurora to see. So this is what we saw.
Wow.
Nice.
Wow.
Nice.
And you could see them dancing about very easily with the naked eye. And then there were
Oh,
some really tall pillars that were off to the left that really went up, and it was absolutely amazing. You could hear all the screams and excitement from the women and the girls when they come up to the camera and see them, because they can't see them with their own eyes. So showing it to them on the camera, they were absolutely ecstatic.
Nice view of Perseus there. Is it on the right?
Yes, it is actually.
Yeah.
I was facing north.
Yeah.
Ish. And then you've just got the bottom part of Cassiopeia there. I've just cut off part of Cassiopeia. But well spotted.
Beautiful.
Yeah.
Yeah.
Lovely colour.
Yeah. And here's my little effort with the Dumbbell Nebula.
Oh.
And this was done with my 180 Mac.
Wow.
Yeah.
Not a telescope, then?
No. It was a dirty Mac.
No, I thought it might have been.
Yeah. So I was a bit dubious because it's like an f/15 aperture, but I managed to put a 0.5 reducer in there, which certainly helped. And the fun thing was this was only a 47-minute integration made up of 15-second exposures.
Oh, there's some good detail in there.
Yeah, there was. Unfortunately, it clouded up, so I couldn't do anything more than the time that I had there. But I'll give it another go. Then you'll be able to see more of the wings over the other sides of the dumbbell, which many people seem to be achieving better now.
Wow.
So that was quite fun. So the night before last, I was at Avebury with the same group of people, and we wanted to go and do some more meteor hunting and the Milky Way. And this is what we saw at Avebury.
Oh, wow.
So we got Avebury Stone Circle, the Milky Way, and a Perseid running down the side.
Lovely.
Even in line with the plane for the Milky Way.
Yeah,
look at that.
Just as a coincidence to that as well, yeah. How fortunate.
Beautiful.
Yeah. So that concludes our large gallery for this week.
Thank you very much, Roger. That's absolutely great. Yeah. So again, thank you, viewers, for sending in your images. And if you would like to send in any images to our weekly gallery, then put them in an email, attach them to an email, send them to spaceodditieslive@gmail.com. That's spaceodditieslive@gmail.com. One image per email, please. And if you could put the word gallery somewhere in the subject of the email, so it will be picked up by the automated system and put in a place for Roger to find. Because we have to help him like that, obviously.
Yeah.
Yeah, he's getting a bit past it to look for these things himself. So we try and give him all of the help that we can in terms of technology. So thank you for that. That's great. We do love seeing your images. You know, as we said, they don't have to be about deep sky objects or meteors or anything in particular. Like Michael, who's just submitted a couple of really nice skyscapes, and we love seeing those equally. Anything to do with the sky, we're there for it. So please keep those images coming in, and thank you very much to those of you who have. And perhaps, I'll mention it. I'm not making any promises, but perhaps we will this year think about doing a calendar.
Oh, not the C word.
Yeah, the C word. I'm not going to mention
2026 one, is it?
Yeah, it's something like that. Yeah. I'm not going to mention the other C word as we're only in August.
Yeah.
But that might be when we will do it. But this time,
is that going to be the 8-month calendar?
Yeah, that's right. That's right. It's going to be called the Starliner calendar. You can make dates. So this time we will endeavour to actually get dates on the calendar. I think we'd still like to do it. We'd still like to offer you a proper calendar with a selection of your best images that you've sent in on. So we'll talk about that nearer the time, nearer towards the C word. So there we are. We'll talk
Yeah,
about that.
I've still got some copies of the unique calendar that we produce. So
Have you? You still got them?
yeah.
Yes.
They're collector's items now.
Yes. Well, if we ever have another war, you can use them to black out your windows or whatever.
So much collector's items, Daz. You've got the only ones.
Collector's
No,
items. Yeah.
No, people did have them, but they made just basically lovely little. All the images were in there; they were fine, but it was a complete cock up with the dates. So
yeah. For those of you who don't know, sorry, it's just a bit of a tale of woe we had the Christmas before last, because we decided that we put some of our favourite images from the ones you've sent in on a calendar for you, and offer that at the C time. And we used a company that said they printed calendars, and we weren't quite aware of the fact, and they did make it clear that if you wanted to include dates on your calendar, you actually had to tell them that you wanted dates on the calendar. So we got a load of calendars back without dates on. So that was a bit of a sorry tale, and we determined not to make the same mistake. Yeah. Anyway, moving on. Well, it's time we came to you, I think, isn't it, Daz?
Oh yeah, okay then. If everybody wants to go to bed, then they can go up the wooden hill now. So right, okay then. Let me just
sort yourself out there.
Yeah. Where have I gone? There I am. So you should.
There we
see
go.
The image. Right now, I've got to go. Let's get this right.
Okay, well, as normal, Daz is going to tell us about the sun. It's been quite an active week on the sun, as we've already seen from the images of the aurora, but we want to know, is it going to continue? What's the prognosis? And he's our man for the job.
Right, so, can you see my cursor? No, nor can I.
Yes.
There it is, yeah.
Yes.
As long as you can see it. Right, okay. Right, I just want to start this with, it's not a moan, but as anybody who follows us weekly, I always sort of like preface most of the things that I say that this is predictions. Nothing is actually written in stone. It's only been since the sort of like the 70s that the study of the sun has become a major science. And that's when we first got space-based telescopes, where the sun could be viewed in different wavelengths and using coronagraphs. But since then, we have learnt a hell of a lot. But there is probably 12 times as much we don't know. So don't ever take this as written. And also, when you use these sites, don't take it as gospel as well. It's our best guess. It's as simple as that, because there is so much involved, especially with aurora, that it'll happen or it won't. And you can have probably one of the most beautiful flares and CME. It'll come towards us. If the magnetic fields inside that CME are not correct, you won't see anything. It's as simple as that. And we don't know how these things work. And also, every country, technological country, has a space weather network. So I tend to use, NOAA, they deal with the America. So all their information is American sort of based. So it's all geared towards what's happening in America. In the UK, I use the UK Met Office. The data they use is the same. But and of course, any other country, say France, Germany, or anything like that, they'll all have their own space weather communities, and they will be producing the same. And they are different. And the obvious thing is they're all in different time zones. So they are going to be different, and they do produce their own data, their own images, their own animations, and things like that. So, as I said, don't take everything as gospel that you actually see. It's all predictions. So if it doesn't happen, it doesn't mean that everybody's failed. They don't know what they're talking about. If you're not using NOAA, you're using another site. It doesn't mean you're using fake data. It's if you go and look at these different sites, you will see they are different. They use the same methods, but the data is different, and even the animations and everything are different. So don't take it as that we know everything, because we obviously don't. So I just wanted to get that out there. Secondly, sorry. So let's get on with this. Now I've got these the right way around this week. If you remember last week, I had them around the wrong way. So we started with on the 6th, where we had 8 active regions on the sun's face, and we finished the week with 11 active regions. So on the left hand side you've got the 6th, and on the right hand side you've got today. That is what the sun's looking at now. We started the week quite sort of like busy-ish. It hasn't been much of a week as regards flares. We've had 109 flares, most of which were C-class flares, so they're the lower ones. But remember, they are still sending us radio interference and solar energetic particles. So they do have an effect on our magnetosphere. So we did have some M-class flares, but that seemed to sort of like peak about midweek, the M-class flares. We did have one X-class flare, which was on Thursday, which was an X1.3. So what we're going to do is I'm just going to go through this. Where's the arrow? No, wait, let's try this. Oh, sorry. So this is what the spots we have got, the active regions we have on the sun at the moment. As you can see, we've got 4 regions that have a complex magnetic structures inside them. And of course, these are the ones that are more likely to give us the larger flares. But as you can see, there's only one that's growing, that everything else seems to be declining, or they're stable. So we're looking basically at 3780. That's been giving us some stuff during the week. But everything else is sort of like settling down. But of course, all these, even the C-class flares, the M-class flares, as I said, they're sending us stuff, and it's banking up and it's coming towards us. And this will disrupt our magnetosphere, which is our guard against all the radiation from the sun and things like that. So it will actually start to rattle, and it'll become not unstable, but it'll be rattling. It's ready for something. If something big comes along, it will, as I've said before, it will strip the magnetic field lines backwards, like peeling a banana, and then that will then, if the configuration's right, will allow more SEPs, or solar energetic particles, to return from the far side of the Earth back into the magnetic poles, and then that will give us aurora. So, but we've had aurora most of the week, but it's mostly been up around the Arctic Circle. They're sort of like G1 storms. And what we were waiting for is something a little bit bigger to come along. Now, it was predicted that we would be getting something over the weekend. And I did put out warnings that just expect something. There's no guarantee. I didn't think the first hit would be very big, which it wasn't. But Sunday was a bit dull until literally Monday morning, and then it really hit us. So I'll just move on, see what we've got next. Right, this is a week on the sun at 304 Armstrongs. This is in 60 seconds. You can see there's CMEs lifting off. You can see flares firing off. There's action on the limb, especially the eastern limb, with what's coming around. and this is what's basically on our sun at the moment. There's a big filament at the top, but that's not really. But you can see all this stuff puffing off, especially on the eastern side. It's all firing off. You can also see there's a dark spot up in the sort of like 11 o'clock thing just coming in. Quite a big, large area. If I just circle it, if I can find my cursor, just around here, that is a coronal hole. So that'll be giving us enhanced winds, which will blow anything that's coming towards us. Give it a bit more oomph. And if you look on the eastern side, there's a lot going on as everything disappears off on the far side. So we'll just let that finish. Right, we'll just go through. Now, this is the coronagraph. Now, on the 8th, you will see, if you can see the little numbers at the bottom of the date, on the 8th, you will actually see that 1.3 X flare that goes off. And it does produce quite a big halo. So we knew something was definitely coming our ways. But you'll see there's not a lot going on, but you get these odd puffs going off. That was before the 8th. The 8th is just coming up. Oh, we've gone past that. But there's a big expulsion. But all this stuff that's going on is actually on the sun side. We didn't see the big far side explosions we had before. So there's another one just going off. So yeah, this is the stuff that was sent our way. It's probably, and over the weekend, it probably banked up. And that's why we got that massive hit on the Monday morning. And it started for us about 2 o'clock in the morning, because I was out and about on Sunday night trying to have a look-see, also see if I could see any meteors, but nothing happened. And then when I decided to go to bed, it all kicked off. So yeah, and some people were lucky enough, they had their cameras still running for Perseids, and all of a sudden they were greeted with images of meteors with an aurora. So yeah, they were very, very lucky. We'll just run through this course, and now this one we're looking at the magnetic field lines that are connecting the active regions. You can see them growing. You can see material moving through them. You can see what's coming on the eastern side, which is just coming around. This is all the stuff that was giving us all the rear side action. So you can see there's things going on. And as you can see on the east side, there's a real big region coming in now. But on the right side as well, there's stuff firing off. So it is, and like I said, this stuff was beginning to fire towards us, and so this is how it all banked up, and we got what we got. And it was, to be quite honest, it was really stunning what we did get. As I said, it started Monday morning at 2 o'clock, and it was still going at 2:30 yesterday morning. No, this morning, when I decided to knock it on the head because the clouds come in. So there's just one more quick video. This is the one where you get the nice flashes of things firing off. This is sort of like just the last 48 hours. In fact, I think it's 48 hours from yesterday, so it doesn't actually cover today. But you can see there is action going on. You can see all these little flares. There's things lifting off. You can see the areas brightening, then darkening again, which usually means something's actually lifted off and is coming towards us. So there we go. Right. Oh, this is the X 1.3 that happened on the 8th of August this week. And you can see how bright how it lit up, but also you can see on the far side the disruption in the coronagraph, and you can see the halo, and that's why and this is probably what really boosted what we got towards the end of the weekend, and Monday especially. So that's quite handy to watch. Now, this is from the actual coronagraph is from a site called Cactus, where it literally it puts everything that's happened on the sun and as a coronagraph, and it tells you which has got coronas and which is something to look out for. So that's another one you can be looking for, Cactus. Right, here we are. Now the main event as it happened. As you can see, we all through last week, we were sort of like up and down, nothing major going on. So it wasn't until, like I said, You can see on Saturday night we started to pick up. We even got to G1, which is a minor storm on the Saturday. But then when we come to Sunday, which is the 12th, if you look for the 12th, it's about 2 o'clock, bang, everything fired off. And it stayed like that for, well, virtually you can see it's been literally almost 2 days that we've had disruptive weather. I've just checked on Aurora UK, the KP index, and it's all totally died down again for the minute. But this is what it started. And of course, it did the usual trick. It started in the afternoon on the Friday. And of course, we were all, oh, has it arrived early? Is it going to carry on? And then, of course, the same on the 12th. Of course, like I said, we just watched it, and it was just absolutely amazing. And we got some images. Now, the story I was going to tell you is I was out to photograph Perseids. I had 3 cameras out, all pointing in different directions. As John said, you can't look in the other week. You can't look at one place. You've got to have eyes all over the place. So I had them pointing in different directions. But of course, one of the first things I noticed as soon as it got dark, well, it wasn't even actually dark. It was just getting twilight, and I noticed the pink hue, and I thought we've got an aurora going on. So of course, got out with the phone, got on the camera, went on to night mode, fired off a shot, and there it was. We immediately before it even actually got started, the aurora had started. But of course, as the things went on, I set my cameras up to capture meteors. So off we went and all that. I took a few photographs with my phone of the aurora, and all the other cameras were firing away. And then, of course, I thought, well, we're sort of like an hour or so into the run. So I think, right, I'll do is I'll change the memory cards and this, that, and the other. And I'll go and start analyzing them. And as soon as I went in, especially the DSLR, my Nikon, all I had was literally almost a pink screen, and I could just make out very faintly the dots of the plough. Basically, what was happening is the aurora was overwhelming the sensors in the cameras. And of course, so I tried to adjust the cameras, but then, of course, everything was too dark to capture any of the faint things. I couldn't see the Milky Way. So in the end, what I had to do was move everything towards the house into the shade, because the back is southward facing. And I was just taking images out towards the south. But on all the cameras, on the right-hand side where the north was coming, it wasn't even actually north, it was coming from the northwest, you could see this glow. And it was literally, as you were going through each image, you could actually see it grow and then shrink back again, grow and shrink back again off of the right-hand side. So basically, it was excuse the French, but it knackered the meteor watch. Couldn't hardly get any of the images, and then, but of course, then we had a glorious aurora. So that's what it looked like in the KP index. Now, this is an image I took with the phone. It was a 6-second image. Now, I apologize for all the wiggliness, but that was because I was holding this by hand. And I hope you can make out there. You can see the Big Dipper, and you can see the really pink hue behind. And as I said, this kept growing and then shrinking, growing and shrinking. And occasionally you could see some of the curtains. But that was when I went through them later. But then, of course, then they were sort of off to the right-hand side, so they weren't really. But this is what you can do. I would have put this on a tripod, but of course, all my tripods had cameras on. I had 3 tripods, 3 cameras. But that was just handheld for 6 seconds, and that's what we basically were looking at. So, what about what's coming up? Oh, sorry. Now, this is the far side, as I said. Now, remember, the grey bit is the Earth side. The orange bits are what's coming from from behind. On the left-hand side this is what's coming onto the face of the sun, On the right hand side is what's going off, and as you can see, there's a lot more black marks coming around. So we're going to be having more activity come round. And basically, as the prediction says, this is the UK Met Office, and for just to prove it, it says in the bottom there, Crown Copyright Met Office. So for the person who doubted it, saying that they don't make their own animations, they use exactly the same data, but of course it's got to be different because all the time there's a thing called time zones, that everything's going to be different. So as you can see, we've gone past the 12th and the 13th. Let me just see if I can start this again for you. I doubt if I will, but let's have a look. No. Right, so that was basically it. But as you can see, it's all dying down. There may be something picking up a bit later on. But at the moment, we do have very fast winds. So that could actually be interesting a bit later on. Okay, then. So
thank you very much, Daz. That's fantastic.
No worries, mate.
Right. Yes, if you obviously have any questions for Daz, then do put them in the chat. I'm just checking to see whether we've missed anything. So there we are. Okay, so we will wrap things up for the evening. Thank you so much for being with us tonight. As always, we do appreciate your company on a Tuesday evening. Just want to bring Lou back in for the grand finale, when Lou's going to do some tap dancing for us this evening. And
the main act.
Yeah.
Perhaps a waltz, but not.
Perhaps a waltz. Okay. All right then. I used to do tap dancing, but I kept falling in the sink, so I had to give it up. Okay. So, thank you very much. Lovely to see Aaron back this evening. I hope you've enjoyed yourself, Aaron.
Yes, very much. Continuing to have video issues. I'm not sure what it is, and it also keeps losing you guys. So, really bizarre behavior. But
really bizarre.
But I think the picture will do me justice in lieu of a video.
Yeah, it makes you look like Plato or something like that. It really does. It's quite distinguished.
Well, I kind of like the disembodied head in space.
It's been mounted.
You're an extra from Zardoz. So, do you remember that? The floating heads. There we are. All right. Well, it's been a great evening. Thank you for your company, ladies and gentlemen out there in YouTube land. We'll be back predictably next week with more. Not quite sure what yet, but we'll keep you posted. Don't forget, by the way, our new Facebook group, Space Oddities Live, and you can join that if you're a subscriber to this channel. And that's where we're trying to build a community there. So go over there and talk to each other, get to know each other. And this is where we'll keep you posted of everything that we're up to. So if you haven't joined it, you can find it easily enough by going to Facebook and searching for Space Oddities Live. That will find it instantly.
And pre-order Brian and Katryn.
Absolutely. And as Brian said earlier, he's posted in our group today a link where you can pre-order his and Katryn's book, Who's Who in the Moon, and get a discount. So now's the time to do that, and obviously we wish them the very best of luck with the book. So there we are. So that's it from us for this evening. So I'd like to thank Roger and Michael and Aaron and John and Daz, and Lou.
Thank you.
John, I hope your fibre optic stays up.
So do I. Yes.
Yeah, it's always touch and go when you first install fibre optic.
Mm-hmm.
We were lucky when we had ours installed because a guy turned up from the telecoms company. It took him 2 days, but he was absolutely brilliant, and he was out there in the pouring rain over 2 days installing everything for us. So you can get lucky sometimes, and we haven't had any problems since, to be honest.
What was it, digging a trench as well, haven't they?
Sorry?
Was he digging a trench as well?
Well, no, he had to lay quite a long cable from the road, let me tell you. And it had to go right to the back of the property and then forward again to the property. So it was a long and involved job. We haven't had any problems since. except the time that the cat decided to destroy where the fiber optic comes into the house, the junction box on the wall. The cat decided to completely destroy that. But the guy turned up again, and he made a sort of a cat-proof junction box. So far it's worked. All right then. Thank you all so much, and don't forget we'll see you on Facebook. But if not, we'll see you back here next Tuesday for more Space Oddities. So have a fantastic week. Take care of each other, everybody.